All right, everybody. So in this video, we're going to discuss the adrenal gland, and just like in the previous videos, we are going to be focusing on the hormones and feedback loop, negative feedback loops associated with the adrenal gland. So the adrenal gland, because it is located on the top of the kidneys, and I'm going to go back to this right here so you can see it. So the adrenal gland is located right here on the top of the kidneys. It is a lot of times, or in some cases, like you're going to see right here, going to be tied tightly to maintenance of water as well as electrolyte balance of the body, because the kidneys are going to be used to pee out the various electrolytes if you have too many of them or just extra water that you have in your body. So here we go. Here's a good example of the kidney working with the gland. So, number one, your body recognizes that we have low blood pressure and or sodium, which is one of the electrolytes. So you have low blood pressure or low electrolytes. Before we go any further, low blood pressure is because you have low, typically, H2O, blood volume. What's your blood made of? Mostly water. So if you don't have a lot of water in your blood volume goes down, therefore the pressure goes down. Think of it kind of like if you have a water balloon. If you have a water balloon and you fill it up a little bit, it's most likely not going to pop because the pressure inside the water balloon isn't too high. But if you have a second water balloon and you fill it up as much as you possibly can, that thing might pop at any time because it has a higher pressure. Why? Because it has more water in it, whereas the other one has low water in it. So, anyways, just wanted to make sure that was understood before we go further because it'll help. So, we noticed that we have low blood pressure and low sodium. So, when that happens, our kidneys are going to recognize it and they're going to release something called renin. Renin is used to create angiotensin 1 from angiotensin. Then from angiotensin 1 and the ACE enzyme, we can create angiotensin 2. So, yes, there's a couple steps here, but the point that we're trying to get to is we have low blood pressure and or low sodium ion levels. And therefore, we create angiotensin 2. Once you make angiotensin 2, we are then going to stimulate the adrenal cortical cells to create or secrete aldosterone. Once aldosterone gets released, it is going to act on the kidney to conserve sodium and water. So, in other words, you're not going to pee out as much water or as much sodium. Your body keeps it. When you do that for long enough, your blood pressure and or sodium levels are going to come back to normal. Once they come back to normal or they increase, your body will then stop this process. Right? So negative feedback loop. Once you get back to where you want to be, it stops happening. Okay? So one more time just to make sure we're on the same page. You don't have a lot of blood pressure and or sodium, so your kidneys are going to release renin, which is eventually going to create angiotensin 2. Angiotensin 2 releases aldosterone or tells your cells to release aldosterone. Then when aldosterone gets released, you do not remove the water or the ions, so you stop peeing them out, which is then going to increase your blood pressure and your sodium ion concentrations. Here are the different hormones associated with the adrenal cortex. You have aldosterone, cortisol, and adrenal androgens. Again, they are very similar structures, these steroid hormones. So cortisol and aldosterone are very similar looking, as we mentioned earlier with the steroid hormones. And just one more feedback loop associated with this could be the cortisol secretion. So cortisol is it's essentially your stress hormones. So what ends up happening is it starts all the way back up here in the hypothalamus, like we did before with previous hormones. So it starts in the hypothalamus, and this is gonna release CRH, cortisol releasing hormone. So again, it's a releasing hormone. From here, the anterior pituitary gland is going to release ACTH, which is going to go into your bloodstream. It is going to release or tell the adrenal cortex to release cortisol, and then cortisol will go into the bloodstream. Once cortisol goes into the bloodstream, it's going to have a number of effects on a number of target regions in the body. Here are some of the examples of things that it can do. So it's stress hormone. Once you have enough of this in your bloodstream, it is going to signal your hypothalamus and your anterior pituitary once again to stop releasing their hormones and then stop the process and stop releasing stress hormone. So again, it's very similar to what we did earlier. You realize your body needs something, hypothalamus triggers anterior pituitary to release its hormone, goes to the bloodstream, goes to its target, which in this case is going to be the adrenal cortex, releases its hormone, in this case cortisol, does its desired effects on its desired cells, and then when you have that done, it tells it to turn off. If you have any questions on this section, please just let me know.